Over the next however long this video ends up being, I'll be explaining something that I find really interesting. One of the key features that sets TensorFlow apart from NumPy is tf.GradientTape. Just so you know, this video is not an introduction to TensorFlow or neural networks. Instead, we'll dive straight into what tf.GradientTape does. Its main function is to help with automatic differentiation, which is a fancy way of saying it helps us calculate how things change. This is super important for training neural networks because we need to know how to adjust our model to make better predictions. When we use tf.GradientTape, TensorFlow keeps track of all the operations that happen inside a specific block of code. This tracking allows TensorFlow to compute gradients efficiently. Gradients are used in a process called backpropagation, where the model's parameters like weights and biases are updated to minimize errors, also known as the loss function. In our training process, we start by setting the learning rate to 0.1, which determines the step size for updating our model's parameters. We then define a function that takes the data fed into the model and the true values we want the model to predict. Inside a specific block, TensorFlow records all the operations to calculate how changes in the model's parameters affect the loss. The model makes predictions based on the inputs, and we calculate the loss to measure how far off the predictions are from the targets. We compute the gradients of the loss with respect to the model's parameters. These gradients indicate how to adjust the parameters to reduce the loss. This step is part of backpropagation, where we calculate the gradient of the loss function with respect to each weight by iterating backward from the output to the input layer, enabling us to adjust the weights and biases to minimize the error. We then update the model's parameters using the gradients and the learning rate. Finally, the function returns the loss, allowing us to evaluate the model's performance after this step.